I want to think about this just a little bit differently. I'm saying that his savings, whoever Ben is, his savings will be equal to the money he already has plus the money he earns. Well, he has 100, so his savings will be equal to that $100 plus $5 for each day. So another way we might write this is S is equal to 100 plus 5D because we earned $5 each day. And then if we want to say slope intercept form, we could say that this is Y equals 5X plus 100. So since it's addition, I can write it in any order. Okay, you guys did a very nice job for that one. I'm going to throw a little bit of a trick at you now, and let's see if you can come up with a answer for this question. I could say that this is 50 plus negative 2D. And then once it's written in addition, then I can change the order. So this would be M is equal to negative 2D plus 50. So some of you were very close. You were on the right track. But remember, I could write these in any order. Good. That was a little bit of a tricky one. We've got about 6 questions that we're going to do for review today, and that'll be it. So the first question that I want to take a look at is actually one from one of your HRWs. Okay. So if you have not finished all your HRWs yet, this is a good one to write down. And this. So a store is selling pens for $1.20 each and notebooks for $2 each. That seems important, so let's underline that information. The manager wants to sell $50 total. Well, this is looking like I don't have an initial value. So if I look at what I'm given 2 rates. And a desired total. So when I'm given 3 things that I need to plug in, we should use standard form. What is standard form? Standard form is AX plus BY equals C. So to write this equation, I'm just going to plug in my rates for A and B and my total for C. So I can say, well, if I want to make $50, if I want to make $50 in the whole day, and I only want to sell pens and notebooks, that's going to be made up of the money I sell from pens. Well, the money I sell from pens depends on the number of pens I sell. And they are $1.20 for each pen. Plus, and I'll have to add that to the money I make from selling notebooks. Well, that depends on the number of notebooks I sell, but those are $2 each. So my equation here would be 1.2p plus 2n equals 50. And again, you could write that using our traditional variables of x and y. But this would be, we could graph it depending on which one we want to plug in, right? So if we said that x is our p, x is our pens, and y is our notebooks, we could graph that. Mr. Cruz, move up the paper. Move down your screen. Just kidding. So a theater sells tickets for $14 each and drinks for $2 each. They need to make up $1,900 this month to show the film. What might an equation for this look like? So yeah, good. If we look, we have $14 each for tickets. So 14t. And I'm also going to make money by selling drinks. So that's $2 for each drink. So if I sell D drinks, I'll make $2D. And I want it to be 1900. Okay. I think you're starting to get better at these. Let's try and jump into some new content today. So we've got three ways to solve equations using functions. The first way is algebraically, which just means we look at the equations themselves. Okay, so we look at the functions and we modify, we use our inverse operations. And really, there's only two steps for this. And we're going to say it like this. Set f of x equal to g of x. Remember, f of x and g of x, that's just function notation. Okay, that's function notation. F of x equal to g of x. And then we'll say we solve for x. So let's do a quick example for this one, because we've got the space for it. If I give you that f of x, this function of x, is equal to this value, 5 minus 3x, and g of x is equal to 1 minus 2x, I want to solve this for x. I want to know when they would be the same. So I'm going to follow our steps here, and it says set f of x equal to g of x. Well, f of x is 5x minus 3. So this would be 5 minus 3x, excuse me. 5 minus 3x. And I want to set that equal to g of x. Well, g of x is 1 minus 2x. If I'm going to solve for x here, I'm going to isolate my variable, which means I need to get it on one side. I need to get both x's to one side. So I see I have a negative 3x and a negative 2x. So I'm actually going to move this negative 3x. I'm going to say that this is plus 3x. And if I do it to one side, I have to do it to the other. Normally I like moving the smaller numbers, but this way it'll give me positive x. Then I'll say 5. So let's stick to our red here. 5 is equal to 1 negative 2x plus 3x. So that's just x. And then to get x by itself, I would subtract 1 from both sides. And we would say that 4 is equal to x. So I can solve for x in this case simply by setting up an equation of two functions. And that's it. That's all there is to this. This is going to be probably the method we use the most often. It's very important that we know how to do this. So this is often the quickest. Let's say often quickest. We'll also find that it's also the most exact because there's no approximating, there's no rounding here. We can always get an exact value. But maybe we don't always like solving equations. We do have another option that we could use. The second option we could have is we could use a table. And this is going to involve a couple more steps here. And we'll often use this on a graphing calculator. Okay, we'll often use this on a graphing calculator, but what we'll do is we'll fill in a table for several points. And then we'll find the row where f of x is equal to g of x. Okay, and this kind of involves a lot of guessing, but it could be very easy to use a graphing calculator. Okay, so what we're going to say here is that this is a lot of guessing, but easy with a calculator. So if you have a graphing calculator at home, or if you have the HRW calculator that'll graph stuff for you, this might be a good way to use. But let's set this up. So what this table is going to look like, let's use our two functions from before. We can see that we'll get the same answer a different way. Our two functions said, well, f of x is equal to 5 minus 3x, and g of x, that's 1 minus 2x. Okay, I'm going to try and get you involved in the chat here, so be ready there. Hopefully you're still paying attention and following along. To set up a table, I want a 3-column table. So 1, 2, and 3. So I've got 3 columns here. In the first column, I'm going to put my input. My input will be my x. In the next column, we'll put the value of f of x. And then in this last column here, we'll put g of x. And what I'm going to do is I'm going to fill in this table for several points. So what I need is pick values of x to plug into these functions. So maybe we want to add that here. Pick x values to plug in. What are some x values we should plug in here? Try and find some easy ones. What might be some easy x values we could plug in? I can plug in 0 for x. So f of 0 will be equal to 5 minus 3 times 0. Well, 3 times 0 is just 0, so f of 0 is 5 minus 0, which is 5. And then I would do the same thing for g of x. So what is g of 0? Well, it's 1 minus 2 times 0. So g of 0 is 2 times 0 is 1. Thank you, Antonio. Good. Is 1. Good. Let's have you calculate f of 3. I'll calculate g of 3. And then let's have you do f of 4 and g of 4. So calculate f of 3, please, and then type your answer in the chat box. Yeah, so if I plug in 3 to f of x, 5 minus 3 times 3, 3 times 3 is 9, so 5 minus 9, is negative 4. So negative 4 will go in this column and in the center spot. What do I get for g of 3? Simplify that. So if I take 2 times 3, I get 6. 1 minus 6 is negative 5. And then I have to plug in f of 4. Well, that would be 5 minus 3 times 4. And let's have you try and figure that one out. What do I get if I plug in f of 4? If I plug in 4 for x, what should this simplify to? If I plug in 4 into both equations, I get negative 7. So I circle this row right here. And I find the row. I'll look for the row. Remember, rows will be sideways. Row where f of x is the same as g of x. Well, it's right here. And which x value is that? Well, that's x is 4. So our solution here is x equals 4. So what we said is that since f is bigger than g of x here, I want something bigger than 0. But since f is smaller than g of x here, I want something smaller than 5. So let's try 3. Let's find f of 3 and g of 3. And let's try and do these together. I'll break them into smaller questions. I think that worked out better for us. Let's see. Chase, can you help me out here? I'm going to plug in for 3 for x. So this is 50 minus 5 times 3. What's 5 times 3, Chase? There you go. Good. Glad you're there. And Antonio H, what's 50 minus 15? $35. Beautiful. So f of 3 is 35. All right. Let's see. We got Cheyenne and Jay for these. You guys are awesome right now for us. And let's see if we can get Haley involved here as well. What will the equation look like if I plug in 3 for g or 3 for x here? So Jay, let's have you type in the whole expression here. This will say, if I plug in 3 for x here for g, what will the expression be, Jay? So just like I did here. Good. I've got g is 10 plus 3x. Actually, here, we're doing, so I see where you're at. Okay. So that's very close, Jay. I like this 10 plus, but don't lose this 15. We're plugging in 3 in place of x, not in place of the 15. Okay, so 10 plus 15 times 3. Okay, so 3 just takes the place of the x. But good, Jay. Thank you for taking a whack at it. All right, and let's see. Cheyenne, can you give me 3 times 15? Good, Cheyenne, thank you. And 10 plus 45, Haley, what's 10 plus 45? I think we're all saying it right now. 10 plus 45 is 55. There you go. Thanks, Jay. So did I get one that works yet? Well, 35 isn't the same as 55. But now I can look and say, well, f of x is still smaller than g of x here. So I need a number that's between 0 and 3. So again, these tables can be kind of long because it's a lot of guessing. But what's a number I could try that's between 0 and 3? It's a number I could try between 0 and 3. Only a couple options here. Let's try and finish this one off. Good, we could plug in 1. So let's try f of 1. And then we'll need g of 1 as well. G of 1. Make that a red. Isabel, are you here as well? Let's try and get you involved a little bit today. Sweet. You're quick on the chat box too. Isabel, can you do g of 1 for me? And then let's have Antonio H. Can you try f of 1 for me, please? Antonio Henderson says this here is 45. Agree, that one will be 45. And Isabel, let's take a look. What's 15 times 1, Isabel? 15, and 10 plus 15. 25, there we go. So this one would be 25. Well, they're still not the same. But now f is bigger. So if I squeezed it in. So let's try f of 2 here. Let's see if we can finish this one off. Let's see if 2 works. And g of 2. Now we're trying 2. And Mr. Killam, can you try f of 2 for me? And let's see here. Who haven't we got involved in a minute? And Chase, can you try g of 2? Chase Summer says, I got 40. Nice job, Chase. Let's see if Mr. Killam's there. Nice job typing out all the steps there, Mr. Killam. Perfect, and that way it's in the chat box as well. 50 minus 5 times 2 is 40 also. Nice job, Chase. You were very quick on that. So now look, we get the same answer when we plug in 2. So I'm gonna resketch this table real quick since I ran out of room, and then we'll be done for today. I think this is enough notes. So we said I've got x, f of x, and g of x. And we guessed a whole bunch of numbers. We said, well, what if we plug in 0 for x? If we plug in 0 for x, we got 50 and 10. And we said, well, those don't work for us. And we also said, well, let's try 5. Let's try 5. And if we plugged in 5, we said we got 25 and 85. And we said, well, those aren't the same either. So then we went back up and we plugged in 1 and 3. And we found that if I plug in 1, I got 45, and looks like I got 25. And we said, well, those aren't the same. And if we plugged in 3, we got 35 and 55. And using that sandwich method, where we kind of kept picking numbers in between, we found that if we plug in 2, we get 40 in both of our columns. So our solution would be x equals 2. We look for the x value when the values are the same.